Today, we'll be dealing with network interface and network cabling. I'll be introducing you to the kind of interface we have in our network devices and the kind of cable we use for connecting these network devices together. Here on the screen is examples of a network, whereby you have a PC. As you can see on your screen, you have a PC, desktop, you have laptop, you have a server. All these devices are connected to a switch, and the name of the switch is 2960 24-port switch. And this switch is connected to a router, and the router is connected to the internet, which is the cloud. This is a basic network component. And today, we'll be focusing on the interface and the network cabling that they use to connect these devices together. What type of cable it is, how they transmit, how many data they can transmit at a time. Yesterday, in our previous lecture, I thought you made mention of something called speed at which internet used to transmit the data, which was measured in bits. Now, today you'll be knowing how this cable can transmit the data and how many bits of data can be transmitted at a time for each device. Here is a simple view of a switch. And this switch is 24-port switch. This is the front view, this is the back view. Note, switch does not have off and on button. It only have a place where you can plug the cord, which is here, AC power connector. Immediately you plug the adapter, automatically comes on. That is a switch. That's the difference between a switch. So this is a rear view of a switch, and this is the front view of the switch. This is how the front view is. This particular switch here is having 24 ports. These are the ports. And their RJ45 ports is having 2 gigabit ports. Can you see something here? 10/100/1000 uplink ports.
Uplink port, yes, sir.
Later in the slide, I will explain what this value is and the meaning. But for now, just look at the physical interface of this switch. The rear view, which is the back of the switch, we have a port here called RJ45 console port. RJ simply means register jack. Later in the slide, I will show you what RJ45 is and how it works. Here is a AC power connector where you can connect the power to the power supply, and the switch automatically comes on. This top here is called RJ45 connector. Why this cable is called Ethernet cable? It's a copper cable. And we have some that are not copper, but most networks use a copper cable for the Ethernet connectors. This is a sample and the photo. Here in this slide, as you can see, this is a switch. I brought out this switch for you so that you can see that in this switch, it's having 24 ports also. 1, 2, 3, 4, 5, 6, 12, 24 ports. But at the top of the switch, you can see something that is written here. This is it. 10/100/1000 base T ports. 1 to 24. Ports are auto MDIX. Later in this switch, I will explain the meaning of this grammar for you and what it means. This port is called RJ45 port. And this is an example of a cable that you can put in this port. This is it, RJ45 cable. And the meaning of RJ is called register jack. 45 that you are seeing, the 45 is the size of the connector. We also have the smaller one that is smaller than this. We have RJ11, we have RJ12. And this one is called RJ45 ports. Why that cable is called RJ45 cable? Why the connector on the earth is called RJ45 connector? Here, this is the RJ45 cable. You can see now that this RJ45 cable connector is having pins. And if I should calculate this pin, there are 80 numbers. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Can you see? This is how it's been numbered. The first one is light orange, light green, blue, light blue, green,
Green.
light brown, and brown. Anytime you connect, you have this code as one hand, and you also have the same code at the other hand. That kind of connector is called a straight-through cable connector. These are internet cables. We have two types of internet cables. We have the straight-through and the crossover cables. If you want to put it inside your hard disk file, this is how you are going to number it. You follow this color coded. Here, I say Ethernet. What is Ethernet? Ethernet is a technology that connects via local area network, LAN, and enable the device to communicate with each other through a network protocol or standard. What is protocol? A network protocol is an established set of rules that determine how a data is transmitted between different devices in the same network. Examples of Ethernet cable. We have Ethernet cable. When you look at this Ethernet cable, we have two. We have the fiber cables and we have the what? UTP cable. What is the meaning of UTP? UTP simply means untwisted pair cable. So now, this is the speed of the cable. For example, now look at this cable here that you see here. It's exactly what I'm explaining right now. We have a cable, this port. That's means if you see any switch that have this number at the top, it simply means that that switch can work with 10 Mbps, 10 megabit per second. It can work with 100 megabit per second. It can also work with 1000 bits per second. So now, which means if you have 10 base T, it will work. If you have 100 base T, it will work. If you have 1000 base T, it will also work. That's what this thing is telling you. And this is what it's telling you here. So which means a cable, Ethernet cable, the speed of 10 Mbps is called Ethernet. The common name that we call it is called Ethernet. And the information IEEE standard name is 10 base T. What is the meaning of base T? Base means base band signal, while the T means twisted pair. Now, if you look at this table, it simply means that the speed of this cable called Ethernet is 10 megabits per second. And the standard name, IEEE name, is 10 base T. The standard name, the formula for IEEE is 8023. And the cable type and maximum length is copper. And the maximum length they can ever have is 100 meters. The same way we also have another copper cable again. The speed is 100 megabits per second. And the name of the cable, the common name of the cable is fast Ethernet. And the name is what? 100 base T. The maximum length is also 100 meters. We have, if you go and look at it again, we also have 10 gigabits. The speed of 10 gigabits. And the common name is what? Is 10 gigabit Ethernet. The standard IT name is 10 gigabits base T. And the size, the maximum length of the cable is what? 100 meters. Which means a copper cable can never exceed 100 meters. Anytime you have a network, you are trying to configure a network, and the cable, the Ethernet cable, is longer than 100 meters, your network will be insufficient. There will be a lot of broker storms and all. That's why it's recommended that in your network, the maximum length of your cable, copper cable, must be 100, must not be higher than 100, maximum length. We also have another one, 1000 megabits base T. And this one is what? Okay, this one is copper. We also have 1000 megabit base TS, which is also fiber. And that one is about 5,000 kilometers, the maximum length. That is what they use to run one office, for example, now maybe you have one office at here in Aja, and you have another office at Bega. If you want to lay cable, the kind of cable you will lay to connect your network together is fiber cable. You need to calculate the distance between Aja to Bega. If the distance is up to 3 kilometers, the kind of cable to use is what? Is fiber cable. Immediately the distance is beyond 100 meters, the cable to use is fiber. You can use copper. Here, this is how a UTP cable look like. UTP cable. These are a UTP cable look like. Inside this UTP cable, I told you that is what? Unshared twisted pair. That's the meaning of UTP. Why is it unshared? Can you see that the cable here, they are unshared, like they are folded? And if you count it, there are how many numbers? There are pairs of 4, which is 1, 2, 3. Can you see that?
4.
Exactly. So this is what? This is what's called copper cable that we use to connect network. The same thing with that color coding. If you want to put it inside how RJ45 connector, you firstly put a what? This one, orange, you go by blue, and so on. If you want to follow the color coding, that's why I put it here for you to see. This coding.
Orange, blue.
Can you see that there are 8
brown.
wires, 8 cable wire inside? These are 8 with the colors. That's what you are seeing here. Can you see that it's still the same thing? So just follow the coding and you put it inside your RJ45 connector. Yeah, UTP cable, like I told you before now, when you look at that your switch, you will see, let me go there. Can you see? We have 10 base T, 100 base T, and 1000 base T. Let's firstly take Ethernet ports of what? 10 and 100. I'm trying to explain this thing for you now. 10 and 100 base T. Under 10 and 100 base T, this is it, UTP cable of 10 base T and 100 base T. Have it in mind, a UTP cable that uses 10 base T and 100 base T is what? 2 pair of wire. Out of the 8 wire that is here, they only make use of 2. This wire, we call it pins inside the connectors. So they only make use of what? 2 pairs of pin in this 8 pin that is here. So that's why you see, if you come here, you have 2 pairs of pin. This is a switch. This is a switch. Like I explained to you earlier before now, I said a switch transmits a data. Switch transmits a data with pin 3 and 6 and receive a data with pin 1 and 2. Please note, switch transmit data with pin 3 and 6 and receive data with pin 1 and 2. The cable that you are using is what? On 10 base T or 100 base T. If you are using any of these two cables, your switch transmit data at pin 3 and 6 and receive data at pin 1 and 2. The same way, UTP cable, host and host, which means desktop and desktop. If you want to connect them together, what kind of cable we use to connect them together? Host transmit data at pin 1 and 2 and receive data at pin 3 and 6. Please try to know the difference between the switch and the host. Switch transmits at pin 3 and 6 and receive at pin 1 and 2. Host transmits at pin 1 and 2 and receive at pin 3 and 6. Router transmits at pin 1 and 2 and receive at pin 3 and 6. In conclusion, router, firewall, and host, they transmit at pin 1 and 2 and receive at pin 3 and 6. While switch and hub transmit at pin 3 and 6 and receive at pin 1 and 2. In our next slide, I will give you an examples of what I'm talking about. But before that, let me explain to you what a crossover cable is. We have two types of UTP cable. We have crossover cable, and we also have straight through cable. Crossover cable. When are you going to use a crossover cable? When a single device of the same type wants to communicate with each other, you use crossover cable. For example, look at this host and this host. Because this host transmits at pin 1 and 2 and receive at pin 3 and 6. Sorry. Okay, let me take this as an example. Straight through cable. Why is it straight through? Straight through is telling you that when a router is communicating with a switch, you need to use a straight through cable. Why are you using a straight through cable? You are using a straight through cable because router transmits at pin 1 and 2 and receive at pin 3 and 6. Why switch transmits at pin 3 and 6 and receive at pin 1 and 2. So which means if you are connecting switch to a router, they are using the same pin. That is, if a router is transmitting with 1 and 2, switch should be receiving with what? The same 1 and 2. So that means the cable you are using, what type of cable are you using there? You are using a straight through cable. Let's look at this. Host to switch. Like I told you before now, host transmits with pin 1 and 2 and receive with pin 3 and 6. While switch transmits with pin 3 and 6 and receive with pin 1 and 2. Can you see now? So if this host is transmitting at pin 1 and 2, which pin of the switch will receive it? Switch receive as 1 and 2 and transmit at 2 as what? 3 and 6. So that's why we have what? So what type of cable will you use when your host is connected to your switch? Use a straight through cable because it's just straight. The same pin goes to the same pin. Can you see? 1 to 1, 2 to 2. That is straight through cable. The same way, when you are connecting firewall to switch, firewall transmits at pin 1 and 2 and receive at pin 3 and 6. Switch transmits at pin 3 and 6 and receive at pin 1 and 2. So if firewall wants to communicate to switch, what pin will the firewall and the switch use to communicate? Firewall transmits data at pin 1 and 2 and receive data at pin 3 and 6. While switch transmit data at pin 3 and 6 and receive data at pin 1 and 2.
At pin 1 and 2. I want to ask a question.
Okay.
What if you are firewall and a router? Is it going to be crossover cable you use?
Thank you very much. To answer your question, I said before now, I said firewall, router, and host, which is computer. They transmit at pin 1 and 2, and they receive at pin 3 and 4, 3 and 6. So if firewall and firewall is not transmitting, assume firewall and firewall is transmitting, what kind of, can they transmit with 1 and 2, 1 and 2?
A crossover cable.
The crossover cable. Because if this firewall is transmitting with 1 and 2, this firewall will also be transmitting with 1 and 2. You need transceiver and receiver before a communication can occur. So which means if this firewall is transmitting with pin 1 and 2, the next firewall will be receiving with what? With pin 3 and 6. And that is the crossover cable. Look at this one. This is a switch to switch. Can you see? This switch to switch.
Yes,
The crossover. Do you know why it's a crossover? Do you know why we are using crossover here?
because both of them are switch, and you said the receiving end must be with the transmitting end, and the transmitting end receiving end. So that's how we use.
Thank you very much. So which means the kind of cable to connect switch to switch is called a crossover cable. The kind of cable to connect host to host is called a crossover cable. The kind of cable to connect router to router is called a crossover cable. The kind of cable to connect firewall to firewall is called a crossover cable. If I may ask, what kind of cable will you use to connect router to switch?
Straight through cable.
Router, host, which is computer, and firewall, they transmit at pin 1 and 2, and they receive with what? With pin 3 and 6. Why switch transmits at pin 3 and 6, and it receives at pin 1 and 2. So now, if I now want to communicate between a router and a switch, when my router is transmitting at 1 and 2, what part of a switch is receiving?
1 and 2.
Exactly, 1 and 2. So which means my router and my switch, they are using the same pin to transmit and receive.
So straight through.
That is why we are using the straight through. And in the process, whereby your device is transmitting at one point and receiving at the other point, that kind of process is called a full duplex. Full duplex transmission. Full duplex is when device can transmit and receive at the same time. While half duplex is when device can transmit but can't receive at the same time. When you can transmit and you can't receive at the same time, it simply means you need to transmit first before you can receive. And this is examples of a full duplex. Summary of what we've been saying since. PC, which is computer, network interface card, transmit at what? Pin 1 and 2, and receive at pin 3 and 6. Router transmit at pin 1 and 2, receive at 3 and 6. Wireless access points, it transmits at pin 1 and 2, it receives at 3 and 6. Hub transmits at 3 and 6 and receive at what? Pin 1 and 2. Switch transmits at 3 and 6 and receive at where? 1 and 2. Here I'm talking about due to modern technology. Before, if you have a router and you have a switch, I'm talking about the old router before that we have, old iOS, router with old iOS, and you have a switch. You connect them with a wrong cable, there will never be a communication between them. But due to the modern technology that we have now, we now have a switch that's having auto MDIS. Can you see it here? Auto MDIS. If your switch, if you can see it written on top of your switch, auto MDIS, it simply means that either straight through or crossover cable, it will work without any kind of breakage. And what that one is telling you now is auto MDIS, what it does is, if assume now you want to connect switch to switch together, normally you should have used a crossover cable. But with the help of auto MDIS, if you use a straight through cable, it will automatically match the pin to the right channel. That's what this one does. That's why with the help of the modern technology, we don't need either straight through or crossover anymore. Either you have straight through or you have crossover, it will work with your network perfectly without any kind of delay. But for the purpose of your exams, you need to know a straight through and a crossover cable and device to use to connect them. But in a real network, real life network, you don't really need it anymore. You can actually use any cable to connect to the network and it will work perfect for you. That's what auto MDIS does. They use two, which is pin 1 and 2 and 3 and 6. But for the 1000 base T and 10 gig base T, they use a pair of wire, which is 4 pairs, and each pair is bidirectional. It's used for transmitting data or for receiving data. And that's why you see, if you're using this cable on your network, it will be very fast than when you are using that 10 base 2, 10 base T, or 100 base. Because this one has the ability to transmit and receive data at the same time. And the speed at which this one can transmit the data is very higher than the speed at which the 10 and 100 base T use to transmit the data. And that's why you see, I put it here that each pair is bidirectional. Can you see? Bidirectional. It is used for transmitting data and receiving data. Now we'll be talking about the other type of network cable, which is fiber optic cable. These examples of a fiber optic cable. Can you see it? This thing is called SFP transceiver. It's called SFP transceiver. The duty of the SFP transceiver is for you to put this thing. Can you see this fiber optic cable? You put inside this SFP transceiver, and you put this SFP transceiver inside a switch or router. This example of a router. Look at this router. It's having just common 4 UTP ports, which are RJ45 ports. But look at these ports. These are called SFP ports. Can you see now? So if you now want to connect your fiber to this port, you first need to go and buy this thing first, this SFP receiver. Once you get the SFP receiver, you put your fiber inside here and here. Then you take this SFP receiver and you put it inside any of these ports. Can you see it now? This is your router. Like I told you before now, I said router has what? Off and on. This is the off and on of your router. You turn it off, you turn it on. This is also your router. It also have what? Power, AC power supply. That is where you can plug to the what? It's having a port where you can plug it to the what? To the power supply. This is the port. This is the off and on. It's also having a USB port. If you're using a RJ45, you connect your RJ45 to the port of what? UTP port, which is what? RJ45 port. If you're using a fiber, you go and look for what? You go and purchase SFP transceiver and you put it in any of the fiber ports, which is this. If you're using a USB, you use this port, called USB port. Do you understand now?
Yeah.
Now look at this router. How router actually work? How was for fiber optic actually work? For the fiber optic, this is the cable. Look at this cable. Can you see that there are two? 1, 2, 1, 2. One is transceiving and one is receiving. That's what he's doing. One is a transceiver and one is a receiver. As one is transmitting, the other one is receiving at the same time. When this one transmits, this one receives. This one receives, this one transmits. As if you have a router here, you have a router here. This router is in Abuja, while this one is in Lagos. If you use a fiber cable, a port here of a fiber cable will be transmitting and other pair of a fiber cable will be receiving. The same way, if this one is transmitting, this one is receiving all at the same time. There are two types of fiber. We have a single mode fiber and a multi-mode fiber. Characteristics of a single mode fiber. Characteristics of a multi-mode fiber. The multi-mode fiber, the core diameter is wider than the single mode fiber. This is the multi-mode fiber. I will still show you the word single mode fiber. It's a lot longer cable than UTP, but shorter than a single mode fiber. Multi-mode fiber is an alternative that we use over a UTP cable. Because a UTP cable maximum length is what? 100 meters. It can never exceed 100 meters. So the question now is, if I have a distance of 112 meters, what kind of cable am I going to use? You use a fiber cable. What type of fiber cable am I using? You use a multi-mode fiber cable. That's why we put it as part of the characteristics, that it allows a longer cable than what? UTP, but shorter than single mode fiber. If you want to lay a network from here to Akure, you can't use a multi-mode fiber. What kind of fiber will you use? You use a single mode because it has the longest distance ever. Do you understand now?
Yes, so that's the longest distance.
Yes, that is single mode fiber. Why multi-mode fiber is longer than UTP, but shorter than what? Single mode. Multi-mode fiber allow multiple angles of light wave to enter the fiberglass core. Can you see? Can you see multiple angles of light wave that's entering into the fiber core? That's multi-mode fiber. down, Grace. Dami, can we continue?
Yes.
So this transmit, I've explained this to you. At pin 1 and 2
Yeah.
receive as what? Pin 3 and 6. And in the process,
Yes.
whereby your device is transmitting at one point and receiving at the other point, can you see that they are different cable?